1, coordinate plane. So with a coordinate plane, you want to keep in mind of your quadrants. You just have your 4 quadrants within your coordinate plane. The top right is quadrant 1, top left is quadrant 2, bottom left is quadrant 3, bottom right is quadrant 4. Literally counterclockwise from up top right all the way around. With this section, we are going to be going over the distance formula, which is just the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to be getting 2 points, and we're going to be finding the distance between those 2 points. If we look at the first example that we have here, we have the ordered pairs 1, -2, and 8, 9 that we are comparing to the point 5, 3. So we are finding which one is closer to point A. So we're going to start with P, which is 1, -2. We're going to work with A, which is 5, 3. So we're just plugging this into our distance formula. So the square root of the difference of our x values. So it's going to be 5 minus 1 squared plus 3 minus a -2 squared. So this is going to turn into the square root of 4 squared plus 5 squared. The 4 squared is 16, the 5 squared is 25. So we just add these. The 16 plus 25 gives us 41, so it's the square root of 41. And we just leave it in radical form. When we do the Q and A, so Q is 8, 9, A is 5, 3. We have the square root of the difference of our x values, that's 5 minus 8 squared, plus the difference of our y values squared, so that's 3 minus 9 squared. So the 5 minus 8 gives us -3 squared, and the 3 minus 9 gives us -6 squared. So we just add these once we find them. The 3 squared is 9, 6 squared is 36. So this gives us the square root of 45. So we see that the smaller amount is that square root of 41. So that distance between P and A is smaller. So P, point P, which is 1, -2, is closer to point A, which is 5, 3. If we find the distance between these points, we are using the same formula. So for 1, we have A, which is -6, 5, and B, which is 1, -1. So it's going to be the square root of 1 minus -6 squared plus -1 minus 5 squared. This turns into 1 plus 6, which is 7 squared plus -6 squared. The 7 squared is 49. The 6 squared is 36. So we do the 49 plus 36, which is 85. So that's just the square root of 85. For 2, we have point C, which is 10, 3, and point D, which is 0, 4. So we're going to do the square root of 0 minus 10 squared plus 4 minus 3 squared. The 0 minus 10 squared is -10 squared, and the 4 minus 3 is 1 squared. So 10 squared is 100, plus the 1 squared is 1. 100 plus 1 is 101, so that's just the square root of 101. Again, we're keeping this in radical form. If you could simplify these radicals, you would do so, but with these ones that we're going over, you cannot, so that's why we're leaving it in radical form. For example 3, we have E, which is -2, -3, and F, which is 5, 7. So again, we're just going to plug it into our distance formula. So we're going to have 5 minus -2 squared plus 7 minus -3 squared. The 5 plus 2 gives us 7. Squared. And then the 7 plus 3 gives us 10 squared. The 7 squared is 49. 10 squared is 100. So it's the square root of 49 plus 100, which is the square root of 149. With the midpoint, that's when you find the middle of 2 points. We just use the formula the sum of our x values divided by 2, comma, the sum of our y values divided by 2. So if we were finding the midpoint between these 2 points, for example, 1a, we have 17.4, b is 9.3. For this one, we are going to do the sum of our x values, so the 17 plus the 9 divided by 2, and the sum of our y values, so 4 plus 3 divided by 2. That 17 plus 9 gives us 26 over 2, and the 4 plus 3 is 7 over 2. We will simplify the 26 over 2 to be 13, and then that 7 over 2 we can leave as 7 over 2. So it's just 13, comma, 7 over 2. For example 2, we have c, which is -4, 6, and d, which is 5, -1. So again, find the sum of your x values, so 5 plus -4, divide those by 2, then find the sum of your y values, so -1 plus 6 divided by 2. So the 5 plus -4 is 1 over 2, and then -1 plus 6 is 5 over 2. So that's just 1/2, comma, 5/2.